Hello, hi everybody. I'm gonna show you a quick demo. I'm working as a data architect for Datastax. I know that Yaya have already told about Cassandra and Datastax Enterprise and so on, and Mona. What I'm gonna show you is a demonstration that is very, very similar in regards of one of project, NG project called Singularity. I know that Yaya has already told about this kind of project. And the demo will be related to this kind of architecture. You're gonna see a topic Kafka. We're gonna use the topic Kafka to extract, not extract, to ingest data to our Cassandra as a service. Our Cassandra as a service is called Astra. And we're gonna access Astra by using some APIs, REST APIs, by the way, and doing some dashboarding using NOI. Okay. And in fact, we will have a Java application that will be the producer for producing some messages that will be pushed on the Kafka topic. Okay, so the demonstration will show you one of the pieces of the tools platform, let's say, that we have built, and it's called Astra. It's our Cassandra as a service. It's very easy to use. It's totally managed on public cloud providers, and Astra is installed. You can use it, let's say, on Azure, Amazon, AWS, and GCP, Google. The first thing that you need to do if you want to, let's say, play with the demo, because I have created a GitHub repo that brings you the ability to test the demo by yourself. The first thing, you have to create a Astra database. Okay, and what is a Astra database? Mainly, you go to astra.datastax.com. I'm already registered, but after you can add a database, and you have a free tier. You can use 5 gigabytes of data, and it's enough for me for doing the demo. Okay. You need to get the database name, the credentials, username, password. You need to download a zip with the keys, private and public keys, and so on. Public keys, sorry, to be able to connect to the database. But it's very easy to use. And by the way, we're gonna use Studio to show you things. I have created a table here. You can see it. Okay. It's called IoT Data Event Row. Mainly, it's a very simple table. You have it's collecting data coming from vehicles.
You have the ID of the vehicle, the type, the route, where is passing, and so on, the longitude, latitude, okay, and the speed. And we have a timestamp for each message that we're gonna store, okay? Just to show you right now, I have truncated the table. I have nothing on it, and I'm gonna show you it right now. No data returned. Oh, okay. Let's feed this database, okay? Let's go. Well, I have to not lose time. I have already provided Astra database. Right now, if you want to reproduce the demo, mainly I'm using Docker, and I'm going to show you the GitHub repository if you want to do it by yourself. With one line of command, yeah, sure, you have to use Docker, but Docker's compose, I have a compose file already pushed on the GitHub, and woohoo, everything is set up. I have my Kafka environment on my laptop with one topic called IoT data event, and I'm using the Datastax Kafka connector to connect to my Astra instance. Okay? Then I have to push the configuration of this the Kafka connector. Mainly it's a JSON file. You have to configure that. You can see the login password. Okay, never mind. And I have put the zip taken from the database, and I have put my mapping. It's a 1-1 mapping to the table, and so on. Okay, and doing a curl, pushing the configuration makes the fact that right now my connector, my Kafka Connect, is able to communicate with Astra. Nice. And right now, let's go launching my application, my Java Kafka producer, to feed the topic that will push the data to the connector, and so on and so on. Let's go. And I cross my fingers to be sure that the gods of demo are with me, and boom, let's go. Oh, nice. 2 messages. Okay. I can show you that first of all, I'm gonna use Confluent Center, and yeah, I forgot to tell you have to create the topic, but I have already created that for you. It's here, and let's go. Messages. Nice. Okay, it's working. My topic is populated. Let's take a look briefly to the database, and oh, nice. It's working. Let's take a look. Okay, it's going up. Nice. Okay, as you can see, it's very easy to use. What I have done, I have done dashboarding also. I'm going to show you, but I have to connect my dashboard right now. Just relaunch my data sources. I have created a connection to Astra, okay, with my credentials and so on, and with the zip file. I have created the two queries for my dashboard. One is I want to let's say do a faceting of my of the speed, okay, of the vehicles. Let's say that I want to have the number of vehicles that goes between 20 and 13 and so on. Okay. I'm gonna save and run. And the other one, it's doing a select. And by the way, Cassandra is using Cassandra query language. It's like SQL, okay? And that's what I'm doing here. But guess what? This maybe I can expand it a little. Okay, this query here, this SQL query, I have done it here. For example, to have this range, the number of vehicles for, and to have all the vehicles that are exceeding the limitation. Okay, 10, and it's flowing as soon as my application is still running. Everything is fine, and it will give me on a map all the vehicles that are going much more than the limitation 50, 55. And here it is. Okay, the number, the facilitization, and here it is, the location of vehicles that are running too fast. Nice. It's working. Let's just take a look if everything. No, this one is not connected. Okay. Well, let's now connect again to my Astra. Seems that it's working. Okay, because I have done also one thing. Okay, everything is running now. Because every 2 minutes, I think so, if I remember well, there is a refresh, an automatic refresh of my dashboarding. Okay, they retrieve the data from Astra. Okay, nice. What I can do also is, because to be able to query the speed and query, let's say, for example, the route ID, I have created some secondary indexes here on the route ID, and makes me, and then I can query route ID. Same for example, the timestamp. If I take a look here on my table, I have a timestamp here. And the partition key is how the data are distributed on Cassandra. It's how the partitions, the calculation of the partitions, mainly they have been done using this partition key. And if you want just to have, for example, all the data between this date, let's say, because I have, and this one, yeah, could be 25. I think that I have begun more or less now. Okay, no, it's here. Oh, what? No. Maybe what I'm gonna do, if I'm gonna check here, no, not this one. Here. Okay, let's check a look. 53. Okay, if I do this one here. Because it's a demo, huh? Don't forget. Okay, and let's say that I want to enter. No. I hope that I have some. Okay, I have some data. As you can see, I can do this query to retrieve on a window time. During a window timing, I can retrieve all the partition if I want to take a look about my data every 10 minutes, every 15, 20 minutes, whatever. What brings on the table also Astra is Stargate. What is Stargate? Stargate, it's a way, it's to facilitate the life of the developer. If I go to Astra, right here, you can see that you can connect to the database, and Astra is bringing automatically for you REST APIs, GraphQL APIs capabilities to interact with your database. It's already coded for you, okay? And Stargate has been developed using OSGI. OSGI it's a way to do plugins, meaning that right now to interact with the database, you have to do an authentication and get a token to be able to interact with the database. And after you can query the database with GraphQL queries, REST, regular REST APIs. That's what I'm going to show you right now. And you can also store JSON files on Astra and Cassandra, by the way. Okay, it's a very interesting project. It's open source, and it's already bundled on Astra. Okay, as I show you on the UI, Astra UI, you can use GraphQL REST. That's what, because Stargate is bundled. Right now, if I can show you here a quick demo, I have to first to retrieve a token, and with this URL REST URL, I have coded here some global variables, but it's my name and my credentials and the database ID coming from Astra. And as soon as I post this REST API up, I get my token, and my token is automatically propagated on Postman. Right now, what I want to do is, for example, to get what I'm gonna do is to get an ID from my database, because I'm not sure that this one here is one. Let's take this ID. Okay, and what I can do is that I'm connecting to my database ID on the region and on the key space. Key space is the name too. For the table, not products. My bad. It's not the right one. The database is IoT demo. Okay, and I want to retrieve for this table the row with this ID. Let's check, and it's working. Okay, it's a small truck with the speed and so on, the fuel level, longitude, latitude. As you can see, it's very easy to use. It's already packaged. Everything is packaged for you. As you can see, you can use a notebook also to interact with Astra. Yeah, let's check if I think that it has. Yeah, it's growing, it's populating. And my demo is okay, it's pushing. Okay, I hope it has been interesting for you. If you want to have more knowledge about Astra, please go to the site, give a try to the free tier. Okay, astra.datastax.com with a Google account or whatever, you can connect it. If you want to take a look to Stargate, it's open sourced, Stargate, and you can participate if you want. And by the way, actually, the plugins existing, it's the authentication one, the REST JSON GraphQL, and many other will come in the near future. And if you want to try the demo by yourself, you can go to my GitHub account, and the project is called astra.iot demo. And I have put everything needed. I have tried to explain how the different steps, but I didn't put the NOE dashboarding on it. I will do it as soon as possible. But you have everything to create the environment on laptop with Kafka. You have to create Astra, but it's not so difficult. And you can give a try to the demo. You can reach me at bruno.gedes, like my name, at datastax.com if you want to have more information about that. And it's okay for me.
J'interviens parce qu'on me demande si tu peux partager tous les liens que tu as mis sur ta présentation.
Ah, bien sûr, oui. Je le partage où? Dans le chat?
Sur le chat, comme ça, moi, je leur partage.
Ok, ça roule. Je le fais tout de suite. Je t'en prie. C'était bien ou pas, alors?
C'est encore live, donc ils t'entendent.
Pardon? Ah,
Tu es encore live, ils t'entendent. Mais j'enlève et je partage les liens.
ça
Merci en
roule.
tout cas.
Parfait.
Je reviens parce qu'il y a des questions, donc je vais te les poster. Il y a pas mal de questions, donc je n'enlève pas le live tout de suite. OK?
Et j'y réponds, là? Oui. Yeah, it's possible. You can use a time to live, but you have to take care that time to live will delete the records. Okay, if you want to have just 2 weeks of fresh records, and you have to take care about tombstones. But I cannot explain deeply what is a tombstone. But as soon as you delete, as the time to live, or you delete by hand data, is not really deleted. It's timestamped to be deleted in the future during one compaction. But and you need to avoid to have a lot of tombstones. But yes, you can do it. And you can reduce the compaction time. Yeah, Astra is available. Maybe I have not been very clear, but Astra is available on all the public cloud providers: Azure, AWS, and GCP. And we have also a Kubernetes operator, meaning that you can use also a Cassandra and our Datastax Enterprise on a Kubernetes environment. Yeah, Cassandra is managing consistency. You have the replication factor that is very important in Cassandra. By many of the time, people use RF replication factor of 3. And after doing the queries, write or read, you need to give a consistency level. The consistency level by default, if you do nothing, is 1, meaning that one of the 3 replicas has to give a feedback to the client, to the driver, and meaning that you are eventually consistent. But if you're using quorum, let's say quorum, it's the replication factor divided by 2 plus 1, the absolute value of the result plus 1, meaning that if you have 3 replicas, quorum needs that on write and read, you need to have at least 2 replicas. You need to have 2 replicas that gives that feedback, meaning that if you're on consistency level quorum on read and write, you're strongly consistent. There is also the Lightwave transaction, but I will not talk about that. Oh yeah, sorry, my bad. Okay. Thank you.